Alright, so let's take a stab at solving another first order differential equation with a initial value problem. So first of all, as always, I'm going to rewrite this as dy by dx plus 2y equals 0. I just changed the notation, right, just to make our lives easier. And now I'm going to multiply multiply through by dx to get dy plus 2y dx equals 0. Okay, now I'm going to move this to the side. dy equals minus 2y dx. Now I can bring this minus 2y to the left to get 1 over minus 2y dy equals 1 dx. Okay, so essentially the goal up to this point is to get it get both sides of the equation into a form that can be integrated, right, with respect to the respective variable. So we have all the dy's and y's on one side, and then the x's and dx's on one side, right? So now we can just go ahead and take the integral, okay, of both sides. Okay, so now this is quite straightforward. So we can pull the minus 1/2 out. Remember that in the integral we can always pull out the constants, because this is just essentially 1 over y times minus 1/2, right? So now this is just 1 over y dy equals x. Well, we can just go ahead and I'm going to go ahead and just integrate this straight out, because this is a very trivial integral, right? So this is just going to be x plus c. Okay, and this is also similarly quite trivial, right? So let's just get a different color, call this some pink. So this is just going to be minus the half times the antiderivative of 1 over x is the natural log of the absolute value of y plus c equals this term, right? X plus c. Okay. So now that we have this, what do? Now we need to solve for this y term, right? So first, I'm just gonna move up here. Draw this divider. And then, so now we have this equation. So let's just multiply both sides by minus 1/2, right? So we get the natural log of y, a constant times some number is another constant, equals minus 2x. So we multiply both sides by minus 2. Okay, so this cancels out, becomes 1, and this is minus 2 again, plus c, which is just some arbitrary constant, right? Okay, so now we can also get rid of this. We can also have just 1c, right? Because the sum of two arbitrary constants is just another arbitrary constant. Okay, so it's not just 2c. It's actually just c, right? Because it's just big C, some constant. Okay. Now, if we take the exponent of both sides, we get the absolute value of y equals e to the minus 2x plus c, right? So remember, when we take an exponent of a logarithm, right, we get whatever's in the function. So whatever's inside the log, we get that out. Okay. All right. So now the next step is to extract this y from this absolute value function. Okay. Now, I've gone over this a few videos, but it's worth repeating. So this is saying that the absolute value, that means the the always positive value of y is defined by this equation. Okay, so y can be negative, this equality holds. Y can be positive, and this equality holds. Okay, so we can, to get this y out of this absolute value function, we can simply write this as y equals some number d times e to the minus 2x. Well, first of all, I should expand this out. So this is, I'm going to rewrite this as minus 2x e to the minus 2x times e to the c. By using a rule of exponents, we can just, this is the same thing. Okay, and then now I'm rewriting e to the c as d, right? So what does this mean? So this means that if this d is such that y becomes a negative number, this still works. If it's some number such that y is a positive number, this still works. So this equality holds no matter what. Okay. So we have our y. Now we have the initial value we can solve for, right? So we are given that. So this is essentially y of x, right, equals d e to the minus 2x. Okay, and we are given that y of ln 5 equals 3. So we have 3 equals d e to the minus 2 times the natural log of 5. Okay, so now what do we do? Alright, so we can so we can use another rule of exponents and rewrite this right hand side. We can say 3 equals d e to the natural, d3 equals d times e to the power of ln of 5 to the power of minus 2. Okay, so it's another rule of exponents and logarithms, right? You can just, this is the same as writing this. Okay, now that we have that, we know that we can just get this out. E to the natural log of something is just the thing itself. So that's d times 5 to the minus 2. Okay, so this is basically 3 equals d over 5 squared. Okay, and d equals 75. 5 squared is 25. 25 times 3 is 75. Okay, and that's the answer. Now we can take the d value and put it back. So I'm just going to take a different color here. So this is the equation that, this is the equation that we actually end up with. Okay, and now I'm gonna take this d and plug it in here to get y equals 75 e to the minus 2x. Okay.